Okay, let's get started. Firstly, let me introduce myself. My name is Li Guiding from Xiaomi Inc., China, Beijing. I'm focused on NUT kernel, include IPC, scheduler, SMP, ARM-arc, memory manager, and so on. Now I'm working on Xiaomi Vela, which is based on NUT kernel. Brief introduction for Xiaomi Vela. Xiaomi Vela is a common software platform across all IoT applications used for smart home, smart speaker, smart sensor, smart band, and so on. So let's get started. First, let's see the picture. In an SoC chip, multi-cores is always the choice. Professional core for the professional things. So how to communicate between these cores is an important thing. Now we provide a solution, Rptun framework. What is Rptun framework? Rptun means remote proc tunnel, a tunnel for multi-CPUs, one kind of IPC. Rptun based on OpenMP. Rptun is a better way for resource shareable. Rptun is a standard communication method for multi-core, multi-CPUs. It can connect it with Linux. Rptun is an efficient transmission method. Important thing, it is easy to use. Then next questions. What does Rptun framework do? First, provide a common lower API for drivers. Second, provide a common API for Rptun service. Here is the picture. The offer is Rptun from services, include syslog, rpmsg-fs, UART, socket. And the middle is Rptun framework. It provides API for the offer. Also, it provides Rptun ops for the lower. The Rptun thread is used for handling incoming message. So let's continue the features. Initialize and set up OpenMP because it is based on OpenMP. And then handle the remote CPU incoming message. And then handle NS band special message missing. Let me explain NS band special message. In OpenMP, before send message, we need to create a talked channel for two users. This channel called endpoints. Create endpoints is actually send a special message which called NS band. The question is if the NS band message coming, but the user hasn't set up, then the message will missing. So I use a list to handle this situation. Okay, next. Here is another map for the relationship between Rptun framework and Rptun services. We can see Rptun services based on Rptun framework. We provide Rptun service both on kernel space and user space. Then let me introduce them one by one. rpmsg-UART. This is designed for access remote shell. It is a telnet or SSH-like protocol. Let's see the picture. If the main CPU has a physical UART and connected with a local shell, and a DSP has no physical UART, but it has a shell. The user wanted to operate the DSP shell. First, we create a virtual console device file. as a new serial driver. In this virtual device, we create a OpenMP and endpoints connected with the remote shell, or remote CPU. The remote CPU also created a virtual device and the OpenMP channel corresponding it. Then we use system command co as a remote terminal entry. co send some chair like PS. Then the PS chair sent to the remote CPU from the OpenMP. The DSP shall receive the PS command and execute in the open CPU. And then he got the PS echo. Then the echo will send back to the main CPU. After the echo back to the CPU, then it can show to the user. Next service, rpmsg-syslog. This is designed for access remote syslog. Let's see the picture. If the main CPU has a physical UART, syslog can directly print to user from this device. And the remote CPU 1 and remote CPU 2 has no physical UART, but they also want to syslog to user. Then, firstly, we create an OpenMP endpoints between remote CPU 1 and the main CPU. Second, set up a syslog buffer for the remote CPU 1. Syslog chairs will put to the syslog buffer. If we meet an end chair, a watermark method meted, then kick a rpmsg, and the worker will send the syslog buffer to the main CPU from the OpenMP. Then the log come to the server. We will check the end chair and then output. In case of crossover the log with another CPU. Also, the CPU 2 can send logs in the same way. Okay, this is rpmsg-syslog. Okay, next service, rpmsg-fs. This is designed for access remote file system. It is a NFS SMB-like protocol. Let's see the picture. If the main CPU can access the flash controller, and it is set up the file system littlefs, but the DSP can't access the flash controller, and it also wanted to read or write file. Firstly, we create a new file system type called rpmsg-fs below VFS layer. Second, we create an OpenMP endpoints connected with main CPU and DSP. Third, we use mount command to mount the rpmsg-fs from the remote. If the application call open read write close API, then the rpmsg client will transfer the operation from the OpenMP. And then the rpmsg server can receive these operations, and it will call the main CPU with real operations from the main CPU VFS. Not only the file system, but also the floater operation. The rpmsg-fs speed up to 10 megabytes per second. Okay, let's see the details data. Here's the compare data between TempFS and rpmsg-fs. This is data from Xiaomi Watch S1 Pro. Clock AP 200 mega, clock CP 100 mega. the upper data from the TimeFS on the AP, the lower data from rpmsg on the CP. Both of them access the sum folder. We can see the rpmsg-fs speed can be 10 megabytes per second when block size is 4096. rpmsg device. This is designed for access remote device. It is same with rpmsg-fs, but focus on single device file. The important thing, pool operation support. Furthermore, we are now planning rpmsg MPD device, rpmsg block device. Okay, next page. Next service, rpmsg-socket. This is designed for IPC usage from APP layer. This is a local socket-like protocol and full socket API support. Each connection will create a new OpenMP endpoint. Okay, from this picture, you can see user can use the IPC from the socket in the APP layer. It is easy to use, band, listen, connect, accept. Both support stream and DRAM mode. Both support block and unblock mode. Also, in the rpmsg socket, we have efficient flow control. High speed to 10 mega per second. Here is the rpmsg socket speed data. This data from Xiaomi Watch S1 Pro. Clock AP and audio 200 mega. Clock CP and sensor 100 mega. This data is measured by Rptun. From this chart, we can see the socket rpmsg high speed to 10 megabytes per second. The number in this chart is megabits. Next service, rpmsg-usrsock. This is designed for access remote network. Network full feature supported. Let's see the picture. In the proxy, there is no network stack. We put the usrsock below the socket layer. Once application calls socket layer, then direct to the usrsock, and then put the operation to the device usrsock. Then we start a usrsock client daemon. From this daemon, OpenMP endpoints will be used, and transfer the operation to the server. In the server, we will start a usrsock server daemon and call the real network stack. About the switch, assume current server with stack is 40 megabits, and the client with usrsock is 11 megabits. 20% off is a bit slow. Now we are working on it to improve the speed. Let's see the others Rptun service like rpmsg GPIO, access remote CPU GPIO. rpmsg RTC is used for RTC sync for all CPUs. rpmsg regulator is used for access remote CPU regulator. rpmsg ORB is used for a multi-core message publish and subscribed method. rpmsg block. It is a distributed clock tree support. And we also have Rptun apps. REXEC. It can execute remote shell command. KVDB. It is a distributed key value database. Rptun ping. It is a tool for measuring IPC latency. Rptun service on a real device. Here comes the history of Rptun service. Earlier in 2018, the Xiaomi 5C, there are 2 cores IPC, Linux and DSP. In 2019, the Unicorn 1 NB-IoT SoC, 3 cores IPC, application processor, communication processor, and security processor. In 2021, Unicorn 2, it is a BT headset SoC, 2 cores IPC, application processor, and DSP. And in the same year, we come out the Soundbox, 2 cores IPC, application processor, and DSP. In this year, a few days ago, we published Xiaomi Watch S1 Pro. It has 5 cores IPC, application processor, and communication processor, DSP, sensor, and TE. Okay, let's see the detail. Rptun service on Xiaomi Vela, Xiaomi Watch SE Pro, 5 cores communication. Let's see the map. This is communication processor. This is audio DSP, sensor processor, application processor, and trusted execution environment called TEE. The connections are reticular formation, so much Rptun service in one chip. Syslog, rpmsg, GPIO, RTC, UART, ORB, usrsock, and so on. Efficient cooperation in multi-CPUs. That is Rptun working there. Okay, we come the questions. How to add an Rptun service? First, we see this function, rpmsg-register callback. It has 4 callbacks. The most important is device created callback and the NS-bound callback. In the server registers the NS-bound callback, and the client registers the device created callback. First, the client device created callback will be called, and it will call rpmsg create EPT function. This function will send an NS-bound message to the remote, and the server receives the NS-bound message. It will call NS-bound callback, and then in the NS-bound callback, rpmsg create EPT will be called, and then it will compare. This model called 0 to 1. Obey this model, there are syslog, rpmsg-fs, ORB, and clock, and so on. Let's see another model, 1 to 1. Also this function, rpmsg-register callback. And in this model, there are no server, both client. Each client will call device created callback and send the NS-bound message to each other. Obey this model is UART, and so on. Then how to send or receive message? Let's see the picture. In the CPU 0, call rpmsg send to send the message, and the CPU 1 will receive the message on the EPT callback. Also, the CPU 1 will call rpmsg send to send the message, and in the CPU 0, EPT callback will be receive the message. Okay. That's all my share. Thanks. If any questions, please send my email.